Hi pre-calc. We're going to do 5.3 today, which is solving trig equations, and they're going to be, most of them are going to be for all solutions, and all solutions mean that you want to write the infinite amount of answers, which is obviously impossible to list. So at the end you'll notice that I'll write an equation that will generate all the infinite amount of answers. Okay, so when you're solving these, it just depends how sophisticated the trig equation is. So for a case like this, where there's just one trig function in the equation, I can just go ahead and isolate the trig. The beginning part of this is going to be repetitive. It's the ending that's new, so that's sort of nice. You just sort of have a... It's not like everything here I'm going to show you is new. So the first thing you want to do is solve this on one rotation like you would in chapter 4. So the tangent is negative in quadrant 2 and quadrant 4. I figured that out from the negative, right? You have to know where things are positive or negative, otherwise you won't know where in the quadrants you are. That's the all students take calculus, or you've just memorized where the tangent is positive and negative. This is rotational trig. It's not graphing it linear like we were towards the end of chapter 4. All right, so this would be over 1, so this is the opposite over the adjacent. So I'm just going to put that on my triangles. Opposite, adjacent, opposite, adjacent. That makes the third side 2 because you've memorized these triangles. Okay, if I'm across from radical 3, the reference angle is going to be pi over 3, or 60 degrees. You've memorized that. And now these two angles are equal in distance, meaning that if I started here and jumped, that's not the clearest way to say it. These angles are equidistant, so meaning, let me first just write this in standard position. I'm trying to say two things at once, which are different concepts. In standard position, this is pi minus pi over 3, which is 2 pi over 3. Okay, so this angle is 2 pi over 3 because it's in quadrant 2. What I was just about to say is that if you notice, the distance from one of these angles is the same. So like if I kept jumping from one of these spots to the other, it's equidistant, which means that these are collapsible into one answer. So I'll write it the long way, and then I'll show you how to write it the short way. So the long way is that the first answer is 2 pi over 3, but you want all the coterminal angles of that answer, so you're going to add 2 pi n, where n is an integer. What you're saying is that this is the answer at 2 pi over 3. I can go all the way around the circle and stop here again and add 2 pi, and that's also the answer. I can go all the way around 2 times and stop here again. So every time you stop here, it doesn't matter how many times you go around, you're going to have this output of negative radical 3 for the tangent. So what this does is it lets you grab all the coterminal angles going positive and negative around the circle that stop here. That's what the 2 pi n does. So like for instance, if n is equal to 0, then x sub 1 is 2 pi over 3. If n is equal to 1, then you have to actually have to add the 2 pi, which makes that 6, 8 pi over 3. Right? If n is equal to 2, then you make it 4 times, right? So 2 pi over 3 plus 4 pi. So let's see, 3, 12, 14, that's 14 pi over 3, and so on. So n is an integer, and it's just going to generate all these values, okay? So that's, I'm going to shorthand this, but that's the first answer. All right, in standard position, this guy here, I'm not going to reteach this. I taught this in chapter 4. Standard position on this guy is 2 pi minus pi over 3. Let's see, that's going to be, did I grab the right guy here? This is, 3, 3, so that's 6. This is 5 pi over 3. So in standard position, so all the answers for this guy would be 5 pi over 3 plus all its coterminal angles. So again, if I'm here and I add 2 pi, I stop here again. If I add 2 pi, I stop here again. It doesn't matter which way you rotate. If you stop here, the tangent is negative radical 3. So this is just saying that you can keep looping around the circle, but you'll come back to the same spot. And when you come back to the same spot, the tangent's going to equal to negative radical 3. So this is 2 ways of writing all the solutions, but it's not the best way because you can actually combine this. You can actually combine this into a much better answer. So the idea is that instead of just like going around and hitting this and going around and hitting this and right, and then you do this one, you go around and hit the right. Instead of like doing them as like separate entities, combine them as one. So I could hit this, travel pi, hit this, travel pi, hit this, travel pi, hit this, and so on. So if you start at 2 pi over 3 and you add pi n, you will hit this one, then you travel pi, you hit this one, travel pi, you hit this one. So this is actually the best answer because these are equidistant, you can collapse them into one answer versus them having to be separate. If these were not equal in distance, then you would have to actually write separate equations for each of them. Okay, but this is the best answer for this one. All right, let me stop here on this one so the video doesn't get too long. So this is the final answer right here. Okay, catch you in another video.